So now let's start with example C. I'm going to split this as the cube root of -8, the cube root of x to the 4th, and the cube root of y to the 5. Now, the -8, the cube root of -8, that's going to give me a whole number, -2, so I don't have to worry about that one. Now, when it comes to the x's, I'm going to do the cube root of x to the 3rd and the cube root of x. When it comes to the y's, I'm going to do the cube root of y to the 3rd and the cube root of y squared. Because the cube root of x to the 3rd is just x. The cube root of y to the 3rd is just y. Remember my exponent, I go exponent divided by root. So now on my whole numbers, because I know the cube root of 8 is -2, so I have -2xy. Now for my cube roots, now inside the radical, to have an x and a y squared. Now for example D, I have the negative. The negative is outside the radical, so I don't have to worry about that one. Radical, 4th root of 32. I'm going to think that as the 4th root of 16 times the 4th root of 2. And then the y's, I'm going to split that as the 4th root of y to the 8th and then the 4th root of y. I know the 4th root of 16, a number multiplied by itself 4 times to give us 16, that's 2. On the y's, exponent divided by root, that gives me y squared. So I'm going to have on the outside -2 y squared. Inside the radical, I'm going to have the 4th root of 2y. Now simplify, I've assumed that all variables represent positive values. Now here, 6, I cannot split that as a number divisible by 9. So I'm going to write this first as exponents. I'm going to write this as 5 to the 6 over 9. Now 6 over 9 can be simplified. The fraction as 5 to the 2/3. So I'm going to do the cube root of 5 squared. Same thing with example B. I'm going to say p to the 2/4, which is known as p to the 1/2. So that gives me the square root of p. Now, when we have different roots, have a root to the 2 and a root to the 3, have different roots, or in different bases, I cannot combine them. If I had the same root, just multiply the numbers on the inside and I'm good to go. If I had the same base and different roots, I'll write it to exponents and combine them. But when we have both different bases and different roots, I'm not going to be able to do anything. So that's going to be my answer. Now we're going to use a rule of a theorem called Pythagorean Theorem. When we have a right triangle, the biggest side is going to be called hypotenuse. The other sides are going to call legs, A and B. Doesn't matter which one is bigger. Now, the important thing here, though, the hypotenuse from the 3 sides, that's the biggest side. And I'm going to write this as a squared plus b squared equals c squared. The hypotenuse is what I write by itself. Now, on the other side, which one is a, which one is b, it really does not matter. So here, use the Pythagorean formula to find the length of the hypotenuse of a right triangle if the lengths of the legs are 4 and 6. My biggest side, it's that one. So that's what I'm going to have by itself. So let me just write this as 6 squared plus 4 squared equals c squared. Basically have that 36 plus 16 is equal to c squared. I know 36 plus 16 is 52. That's c squared. I want to know what c, not c squared is. So c, I want to do the square root on each side. C is going to be the square root of 52. Now, if we can split this 52, we can simplify. In our case, we cannot. Now, for distance, let's say I had a point. There's my coordinate plane. I have a point. The coordinates of this one are going to be x2, y2. Had another point, and the coordinates of this are x1, y1. I want to know the distance between them. Technically, I can create a triangle. The coordinates of this other point is going to be x2 because it's the same x as this other value. And it's going to be y1 because it's the same y as this other value. Now, for me to know the difference on this side, I notice the x's don't change, x2, x2. So I would just have to subtract the y's. I'm going to do y2 minus y1. That's this distance. Now, the other leg, I notice the y's don't change. So I'm going to have to go x2 minus x1. Now, using Pythagoras Theorem, I'm going to come out with this formula. To be honest, just worry about the x2 minus x1 first, y2 minus y1 first. So let me subtract the y's. 4 minus 5. Let me worry about that one first. 4 minus 5, that gives me a -1. Let me subtract the x's. 6 minus a -3. That gives me 9. Now, I'm just going to do the square root of 1 squared plus 9 squared. I know my answer, I have a -1, but since I'm going to square it, the square is going to make it positive. So I have the square root of 1 plus 81, which is better known as the square root of 82. I cannot simplify, so that's going to be it. Let me do another example. Let me worry about subtracting the y's first. Thinking of 3 minus a -1. That gives me a 4. Let me worry about subtracting the x's. 5 minus 2. That gives me 3. So now I'm going to do the square root of 4 squared plus 3 squared. Before I continue, on this fraction, if you can simplify your fraction, do not. Okay. So I have the square root of 4 squared plus 3 squared. I have the square root of 16 plus 9, which is better known as the square root of 25, which can still be simplified to just 5. Looking at this other example, let me worry about subtracting the y's first. -4 minus 2. That gives me -6. Now on the bottom, let me worry about subtracting the x's. 0 minus a -3. That gives me a 3. I know I wrote this as a fraction. I can simplify the fraction, but do not. For the distance, I'm going to go the square root of 6 squared plus 3 squared. Once again, my -6, I wrote it as +6 because it is going to be squared. So I have the square root of 36 plus 9, which is the square root of 45. I know square root of 45 is not a perfect square, but I can at least split it as square root of 9 times square root of 5, which is better known as 3 radical 5. Simplify your radical if you can.